memorize that from here to here. So who is bigger? Lithium is bigger, okay? So we try not to, on the quiz or test, you're probably not gonna have a question like weird ones. We try to keep them on the same period or the same group, just to kind of simplify it for now, okay? The Big Frank is the biggest. Now, electronegativity, okay? Now, believe it or not, and you saw this in the video, atoms and electrons, atoms, they share their electrons. Or when they bond, they're bonding with each other. Hey, I'm gonna give up one electron, group 1. And group 7 is like, hey, I need one electron. Hey, let's bond together. That makes sense. Well, that's what's gonna happen. Now, believe it or not though, due to the electronegativity that each atom has, some atoms are a little bit greedy or stingy. You know, for example, group 7 needs one electron, group 1 needs to get rid of one electron. It makes sense. Why don't we bond together, like, and be friends and share, you know, you give me your electron, I need an electron. Why don't we just bond like Legos or like a puzzle? Makes sense. But when they do their bonding, believe it or not, sometimes they don't bond equally. Sometimes some of them are greedy and stingy, and they're gonna hold the electrons a little bit stronger to them, okay? Rather than, you know, make it even, like, hey, we'll just put the electron right here in the middle in between us. No, they don't do that. So that's what electronegativity means. It's the unequal sharing of the electrons, okay? A measure of the atom's ability to steal electrons. How strong are they? Now, on here, we said noble gases are not included at all, okay? And we said that fluorine has the strongest. Well, why aren't noble gases included? And if you stop and think about it, they're pretty darn strong themselves. They hold on to all of their electrons, all of their valence electrons, and they don't let nobody come and take nothing from them. They are super strong. Now, they're not included because they're not going to bond with anybody though, too, right? That's why they're not included. As we go from the bottom up and as we go from the left to the right or a diagonal, we can see how the strength increases, and they're actually numbered. You can see over here, right, Big Frank, he's 0.8, but fluorine is 4.0. Do you get a periodic table with numbers like this on your test or quiz? You'll get one every single time you take your quiz and test, and it's going to look like this. They're laminated, and they have a chart right here, and you can see they have numbers too. So if you memorize or know that electronegativity has to deal with those numbers right here, you can just easily go and look to see on the quiz or test, oh snap, we're looking at aluminum, we're looking at potassium. Aluminum has a bigger number, he's stronger, he has a bigger electronegativity, okay? So here's what the chart looks like on your notes. Here's what the chart looks like on the test for our formula chart that you get to have. And we'll talk about those numbers a little bit more on a different unit, okay? So, move that out the way. Easy way here, electronegativity. If you look at the numbers, it really helps you out. All right, let's keep going. The next part, ionization energy, or IE, okay? Ionization energy is the energy required to steal the electrons. Now, yes, some of them are stronger and they can hold on, kind of like when you're, electronegativity is, I think of it as playing tug of war. And you've got two people playing tug of war with a rope, and one is a little bit stronger and they can pull the rope towards them. They're both holding onto the rope, but somebody's a little bit stronger. That's how I think of electronegativity. Ionization energy is somebody has more energy and they can snatch up those electrons a little quicker than some others, okay? So it says here, noble gases has the highest ionization energy. But remember, electronegativity, they were not even included. Remember why? Well, because they don't bond with anybody. Why do they not bond with anybody? Because they're so darn strong that they hold on to their own electrons, okay? So, since they are so strong and they hold on to their electrons, as we go from the bottom up and from the left to the right, we increase. And like we said, they are just really not even included. Why? Because they don't bond. Why do they not bond? Because they're so darn strong that they hold on to their own electrons. And if we really had to include them, we would say that they are absolutely the strongest. But they don't bond with anybody because they're holding on to their own stuff. Okay? Let's keep going. It shows you here were some numbers. Ms. Munson, do you have numbers like this when we had to take our quiz or test? No, we don't. We'll have the regular periodic table here, right, with the atomic number and the mass number. And then on this side, we'll have the electronegativity numbers, okay? But if you memorize, look at this. This is electronegativity, which is very similar to ionization energy, right? That they kind of are the same. So if you just kind of know that this one chart is going to help you for both, especially by just looking at the numbers, that would definitely help you on the quiz or test, okay? Move that out the way. So we had a few questions here to answer, and then we kind of had a little recap over here, right? Let me answer those questions for you. I did not answer them, I don't think, on the thing, so let's answer them now. Let me fill in the blanks. What is the most reactive metal group? And hopefully you had already did that, and you wrote alkaline or alkaline metals. What was the most reactive non-metal group, right? Or the halogens? Alkaline metals are group number 1. Halogens are group number 7. Why is that? Kind of like that Uno game. The alkaline metals, they only need to lose 1 valence electron, right? And the halogens only need to gain 1 valence electrons. And they're just kind of like that Uno game. They're right there ready to say Uno. The first moment that they see an electron available, they're going to snatch it up before anybody else, okay? So hopefully you filled that in. If not, there you go. There's the answers. You probably wrote something like that or similar, so either way. All right, notes are done. That's it. Pretty easy cheesy when it comes to the notes. We have the last page. I left this blank on here when we did the video, so let's look at the last page. I don't want to get it wrong by any means. So, alkaline metals, let's go ahead and you don't have to do it now, but at least you'll know what to do whenever you get a chance to. We'll color them, all the alkaline metals, orange. If you want to write the word orange over here, so when you get home, if you don't have colored pens or pencils with you, right? We'll do alkaline earth metals, all blue. Transition metals are all going to be pink. I left it blank. I did not do this on the video because we were going to see each other. We have halogens and noble gases. Let me grab some colors. I've got a green here, so let's do them in green. And then the last one are noble gases. It may be kind of hard to see, but I got a purple. There we go. So we'll color those groups to those colors. But there's actually something a little special when it comes to this over here. We've got arrows over here, so let me go grab another pen. That way we can write it in. Those arrows, zoom out a little bit. Are gonna represent what we just talked about, right? We talked about a few different things, but we talked about atomic radii. Atomic radii goes from here to here, from right to left. So this arrow represents atomic radii. Also, it increases from the top to the bottom, which would also be represented by this arrow, which matches that dark arrow. Atomic radii. The next trend that we talked about, atom trends, was we talked about electronegativity. It increases from the bottom up, so electronegativity. And it increases from the left to the right. And then the last trend that we talked about was ionization energy, which increases from the bottom up. Ionization energy. And then it also increases, just like the electronegativity, they are both kind of hand in hand, the same kind of. Which, ionization energy. Okay? So that's what this part here was for. Now the last part here that we left, or that we have, is our little boxes over here. So our boxes over here, the bottom one is going to be the group number 1. It's just so small, I can't fit it all in there. Group number 2, and you're going to continue all the way to group 8. Now the top number over here, or the top boxes, what happens to that group 1? Group 1 is going to lose 1 electron, so its ionization, its ion is going to look like a +1. Group 2 is going to lose 2 electrons, so it's going to have 2 more positive protons, a +2. So you're just going to go ahead and finish off with the oxidation number. That's what I meant to say, oxidation number. So just fill in the groups and the oxidation numbers, and that's what it was meant for. I just didn't go over it on the video. Now homework number 1. Traditionally what I do is I stamp it and go over it with you, okay? So I'm not going to stamp it today, but I do want to go over it though with you. So homework number 1, let's look at that. I'll stamp homework 2 and homework 3. Homework number 1 looks like this. First part here is we have the chart over here. So I'm going to and they show you, they wanted to know the number of valence electrons. How do I find that? From the group number. They wanted to know the number of electrons it's going to gain, or the number of electrons it was going to lose. And then they wanted to know what type of ion was going to be formed, and what is it going to be called? A cation or an anion, right? So let's go ahead and keep looking at this. Oxygen was group number 6. What's going to happen is that it's going to gain 2 electrons, and nothing's going to happen. It's obviously not going to lose. So it's either going to gain or lose, but it's not going to do both. So oxygen now, the ion is going to look like O minus 2, and it's going to become an anion, right? Calcium, Ca, that's a metal. It's over in group 2, so that means that it has 2 valence electrons. What's going to happen on calcium is that it's not going to gain, but it is going to lose 2 electrons. So now it's going to be a Ca plus 2, because it lost 2 electrons. That means it still has 2 extra positive protons when you compare them. That's a cation. Right? So this was your homework that you hopefully worked and did. and check your answers, because hopefully you did do them. Again, one more time, it's either gonna gain or it's gonna lose, but it can't do both, so you could not have numbers in both sides. Right, then you're gonna get that element symbol, you put it over there, and then you're gonna put, is it a positive or a negative, right? Negative means that it added electrons, positive means that it lost electrons. And then is it a cation or an anion? Anions have a negative oxidation, cations have a positive oxidation, right? So please double check your answers. Also, after we do go over the homework, hopefully you saw, if you haven't looked yet, the answers to the video quiz that you've already submitted, the answers are all on Blackboard now. I took pictures of the answer key and posted it on there. I will go ahead and start doing that for the homeworks too. So now after today, I'll take a picture and I will put it on there, just in case if you didn't get all of it when we went through it, okay? Just so that way you'll have all the information. I don't want you to be missing anything. So now let's look at the bottom part of the homework. It looks like this. If lithium loses an electron to form to another atom, why is it written as a lithium or Li +1 with a +1 instead of a -1 if it loses it? And that's the problem, is that many students think if it loses this, it's gonna have a negative charge. That's not the case. It should have a positive charge. And that's because and you may have wrote something completely different, but similar, all right? It's telling you for the atom, this is what I have. It may not make sense yet. To be it's telling you to +1 for the atom for it to be the original. That doesn't make sense, does it? I don't like that. I know, that's what I wrote last year. I don't know why.
Well, maybe last year it made sense.
Maybe it makes sense last year, right? But I don't make sense this year, not at all.
Well, 2020 didn't make sense, so.
Who knows? Yeah. Ignore me, people. Let's go ahead and say this. Why is it written with a +1 instead of a -1 if you quote unquote lost electrons? Well, it's because it has more positive protons than negative electrons. That makes sense. I like that a lot more. That's a lot better than this. If nitrogen gains 3 electrons from another atom, why is it written as a -3 instead of a +3? Well, that's because, right, it has +3, or it has more +3. That's how many more negative electrons. Right, number 3. What do you think happens to the size of an atom when it becomes a cation? Oh. So a cation means that it has a positive charge. A positive charge means that it lost electrons. If I lost fat, right, I'm gonna become skinnier. I lost weight. So what happens is that it loses the electrons, so it's going to become, I agree, it's smaller. Not much smaller, but a little bit smaller. And the opposite is for number 4. Does that make sense, right? If you're gonna lose something, right, if I lost some of my kids. Now I have 3 kids that drive. So no longer does Miss Munson drive a minivan. I drive a small SUV. I'm waiting to go to a small, like, little car. Like, I just need 3 more to be driving, and that way I don't have to, so my car size is decreasing. That's what I like. I don't need no big old giant minivan anymore. They drive themselves. What do you think happens to the size of the atom when it becomes an anion? An anion is a negative charge, means that it adds or it gains electrons. So it's going to become larger, right? Not much larger, but it's gonna become a little larger. Now, regarding shell size, right? It's not gonna gain extra shells. It's gonna stay. So for an example, on period 2, when you look at the periodic table, which is the second row, they have 2 shells. It's not gonna gain an extra shell. That shell size is gonna stay the same. It's just gonna gain a little bit of weight because it got a little bit of electrons. But remember, those electrons are so insignificant regarding mass. So the size becomes a little bit, but not a lot bigger, not a lot smaller. Let's move that out of the way. Homework number 1. Homework number 2. Tell me if I'm wrong, but I think it looks like this. Homework number 3. You tell me if I'm wrong in a minute, but I think it looks like is this homework number 3? Does homework 3 have a front and back? It has this?
Yes, ma'am.
Okay, it is. Okay. So homework 2, let's look at homework 2 first. Homework 2 is a little weird, and there's a task question with a picture similar to this. So I like this homework because even though it's weird looking, the question, the pictures are similar to the quiz/test. Looking at the periodic table, overall, letter E is talking about this column and this column. Letter B is talking about this column only. Letter C is talking about this column. Letter D is talking about the transition metals, if that makes sense. So I like going over the homework because I promise you you're gonna see the same picture, quiz/test. So it says here, let's go ahead and answer the questions using this periodic table. Identify the element, it says here, that is in group 14, but in period 4, group 14. Well, I would probably go ahead and brain dump or write down 1, 2, 3, 4, 5, 6, 7, 8. Right? I would probably also go ahead and just write down 1, 2, 3, 4, 5, 6, 7. Those are my rows. Now don't forget though, this is truly row 6 also, and that's row 7, right? Those two belong over here. So as a quick reminder, this is row 6 and row 7. Just to make it look a little neater, they pulled them down. So I'm gonna go ahead and put a 6 and 7 just as a quick reminder for y'all, okay? So let's look at this one. 14 is over here, but we're gonna be in period 4. 1, this is 2, 3, 4, GA. I'm telling you, this is easy. The only metal in group 15, go to group 15. Who is my only metal in group 15? Bi. While I'm sitting here looking at this, I'm gonna go ahead and, right, look at my stair step. Just because Bi's little corner is barely touching it does not mean that it's a metalloid. It's a metal, okay? So I'm gonna go ahead and I'm just going to make myself a little bit easier, I'm just gonna kind of color them in a little bit. And those are my metalloids, not aluminum, that's the exception to the rule. Let's keep going. The transition metal with the smallest atomic mass. The transition metal with the smallest atomic mass. Well, you just gotta look at the atomic mass numbers, but the atomic masses correlate with the atomic number. So who's the smallest one? SC. Right here. Okay? So that's how you're gonna do that one. Now let's go look at number 2 at the bottom. It says, using that same periodic table above, area A represents which block? Is it S, P, D, or F? Okay, area A. Well, who's area A? Area A is all of this over here. So that would be block P. And those are gonna be questions similar to the quiz/test, right? So not too bad. Let's keep going. Looking down at part B. Choose from, the periodic table lettering up here. The Transition elements are these middle ones right here. That would be letter D. We haven't talked about them very much because I was hoping you were to look it up when you have your periodic table flip chart to go through. The lanthanines and astenines. The lanthanines are going to be letter I, which is right here, period 6, and the actinines are H. Those are very radioactive. Alkaline metals. Who's alkaline metals? Letter B. Right? So not bad. Let's turn the page. Backside. I'm sorry that I know the notes are back, forgive me, but. So we have the, what do you call it, the next chart to fill in. Na, sodium. Looking at the periodic table, the number of valence electrons. I need to go to the group number, which is group 1, and that's how many valence electrons it is. I'm going to put as a quick reminder for you, this is going to be the group number. Same as the valence electron. Does it gain or does it lose? It's going to lose. How many would it gain or lose? Well, it's going to lose 1, the same as that number. What is the charge going to be? It's going to lose 1 charge, so it's going to have a +1 charge. So if it loses, as a quick reminder, let me just put that up here, it's going to equal a positive. If it gains electrons, it's going to be a negative. Okay, just kind of just throw out reminders there for y'all. Then the last part there, what kind of noble gas is sodium going to look like? Well, sodium, it's easier to lose 1 electron, so I go to the periodic table and I go backwards 1, which is going to be neon Ne. We did this already on the notes. Hopefully this should be no problem. Give this symbol, I'm looking at number 2, period number, group number, and the block number, okay? Block letter is what I meant to say. Don't forget, block is S, P, D, or F, right? The symbol, so sulfur is going to be an S. What is the period number, which is across? Sulfur is going to be in period 3. Group number, column 6 or 16. I'm going to put, we call it 6, but yes, it's 16. Block is going to be, it's over there in that section, P. All right, so shouldn't be hard. We know exactly what all these are. Guess the following elements. Well, you shouldn't have to guess it, you should be able to know it. It says here that I have 7 valence electrons. Well, if it has 7 valence electrons, what group does it must be in? Group 7, right? So 7 valence electrons means that this right here is group number 7. And I don't know what am. In the 5th energy level, where would 5th energy level be this? Period, right? Remember those period? Those rows are the energies, shells or the energy levels. So let's go ahead and let's look. Group 7. And I need to go to row number 5. Who is that? Iodine. Okay? But I like how that question says I have 7 valence electrons, which is the same as the group number. And I'm energy level, that is going to be the row number, right? And another word for energy level would be shells, the number of shells I have, okay? So remember, there's more than one word that can be used. Same thing's gonna happen. You're gonna go through this, think about what you learned, but the questions here are going to use different words. They're not gonna be super easy cheesy, okay? They're still kind of easy, but still though. Let's keep going. Predict the number of electrons of the following ions/atoms. So you're gonna go over here. Calcium has, ion has a +2 oxidation number, and it has 20 protons and blank electrons. If it has 20 protons and the oxidation is a +2, what does +2 mean? It lost 2 electrons. So 20 take away 18, and take away 2 is 18. I get the answer. Does that make sense? I know I'm speaking a little fast, okay? But oxidation number of a +2 means that it lost 2 electrons. I just want to make sure, because I'm going a little quick. Moving homework number 2 out of the way, homework number 3, because I think there's another class that comes in like 5 minutes or so, maybe 3. Homework number 3 looks like this. Again, same questions, very, 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 very similar. The backside, mystery elements, again, the very, very, very similar. First one, for example, is calcium. Number 2, I am a member of the alkaline earth metal, right, group 2, and I have the smallest atomic radii, Be. So you're gonna have to go back and use your notes to help you out. We're out of time, so we're not gonna talk about the flip chart. All of the rules and expectations are already online, but I'm not gonna go over it until we actually see each other on Thursday. Okay? So please print it out. So we'll go over homework 2, homework 3, I'll stamp them. We're done with all the notes. We'll go over the periodic flip chart and then we'll take a quiz next week. Again, this is a pretty easy cheesy, no math at all.
I know, I like it when there's no math.
No math at all, right? No math. I mean, like, y'all got this. They got this.
I'm taking college algebra this semester, I'm already dreading it, haven't even started it.
Who do you have?
I have no idea.
No? Okay.
I don't remember. I don't remember any of
I
it.
appreciate it, thank you so much. Oh, whoa, one more time, one more thing, can y'all rip the number off of your table? Well, good luck on that math, because I can't stand that none of the teachers are really here.
On the bright side, I'm better at algebra than I am geometry.
Okay, well,
I sucked at that.
I would go to Rachel,
Yeah.
right? When in doubt, go see Rachel.
Yeah, honestly.
She's my go-to person.